Alright, all you chemistry fans, here's the most difficult, or one of the most difficult, stoichiometry problems. It's the feared by all freshman college chemistry students, the mass problem. Okay, so let's look why it's a mass. If you read the problem, you'll look and you'll say, okay, they're asking me how many grams, and grams are mass. If I have a certain amount of grams are mass again. So that's why it's a mass problem. So what are they asking for? They're asking for how much iron 3 oxide, say iron 3, because the iron is going to have a charge of +3, as opposed to iron's a transition metal. It also does a +2 charge. That'd be iron 2 oxide. So iron can have 2 oxidation states, or charges, the iron 2 and the iron 3. This is iron 3 oxide. So how many grams of iron 3 oxide, that's that brown rust that you get when you put a nail in water, can be made from, if you had 100 grams of iron and you're going to rust it all. And then of course you need an excess amount of oxygen. So the balanced chemical equation is 4 iron are needed for every 3 moles of oxygen used up, and you will get 2 moles of iron oxide. So let's write down our knowns, or our givens. So what's the known? What do we know from reading the problem? And what does the problem want us to solve? It's the unknown. Just thought of something here. It'd work a lot better if I write with my pen instead of my mouse. So let me get that out. Alright. Try this again. So unknown and known. Not doing too good here at the pen. The known was 100 grams of iron. And the unknown, they want to know how many grams of iron oxide. And why are there 3 oxygens? Because iron has a charge of +3, so iron 3 oxides. So I've got my known and my unknown. Since this is a mass problem, we're going to have to go to the periodic table twice, once for every chemical. So let's get the molar masses. So here's my first part of my table. Here's my second part of my table. And the molar mass of iron, where are we going to find that? How are we going to find out what a mole of iron atoms weighs? Well, we need our periodic table. Here it is. And we need to find the iron on there. Iron is here. So it's 55.85. And then oxygen is 16. So we're going to need those with our molar masses. So the molar mass of iron, 55.85. What's that mean? 55.85 grams for every mole. .85 grams for every 1 mole. Anytime you get the mass of anything off the periodic table, the mass is always 1 mole. Alright, so we're done with that. Let's do the molar mass for iron oxide, iron 3 oxide. So that's when you're having to add the molar mass of chemicals, this little review for you. So we have 2 irons times, what did iron weigh from the periodic table? 55.85. And we have 3 oxygens, right? 3 oxygens here. It's oxygen, not 30. 3 oxygens times, see, they on the periodic table they use 16.00. You'll see it as 15.99 on most, so this periodic table that I found rounded. Get out your handy dandy calculator. I think I can do 3 times 16 in my head. Isn't that 48? And 55.85 times 2. So 55.85 times 2. 111.7. One, 1.7. Add them up. It's actually going to be 0.0, 48.0. We don't worry about this digit. If we did, it would, yes, we can. We can keep 4 sig fig. Nope, can't keep that. So we're going to add the 7 to the 0, 8 and 1, 4 and 1, and then just 1. So 159.7 grams per mole. How many moles? Always we add that to the table. 1 per 1 mole. And now we need our magic fraction. So we've got our molar mass for both chemicals. What's our magic fraction? Every stoichiometry problem, I call it a magic fraction. It's that ratio of the unknown on top and the known on the bottom, chemical, from the balanced equation. So what's my known? Iron. And I put it on the bottom, 4. For what? 4 moles of iron. Every stoichiometry problem needs this magic fraction. And what's my unknown chemical? It goes on the top. Iron 2 oxide. 2. So now I've got everything, I can solve this problem, set it up. Remember, this is the magic fraction here, it's important. Okay, the other common thing that stoichiometry problems all have, they all have in common, you start with your given. Remember, 100 grams of iron. So I'm going to make this dimensional analysis expression 100 grams of iron. I'm going to take times, fraction, and what am I going to put in the bottom? Something with grams of iron. Right here, 55.85. 55, whoop, something happened here. 0.85 grams of iron is always what? Got it from the periodic table. 1 mole. So 1 mole goes on top. Now what do I need? I need something with moles in the bottom for iron. And I have that in my magic fraction, 4. And what was the top number of the magic fraction? 2. Remember where I got the 2 from? Iron oxide. 2 moles of iron oxide times last fraction. I need something with moles of iron oxide on the bottom, and that's back to the periodic table. Iron oxide, 1 mole of it. 1 mole of anything right off the table. So 1 mole of iron oxide, iron 3 oxide, is what? 159.7 grams. Okay, let's make sure we set everything up correctly. If we did, we've got something in the denominator and something in the numerator of the previous fraction that are exact terms. Anything that's an exact term, don't worry about the numbers, of course, but the units, they're exact units. The units cancel out. Let's see again. Mole, iron, mole, iron. Grams of iron, grams of iron. So we've got it done. Last step. Handy dandy calculator. Let's do the arithmetic here. So it becomes 100. And we're just multiply all the numerators together. Times 1, times 2, times 159.7. $31940. So on the bottom, 31940. What did I say on the bottom for? Under this equation, that's the only place I have room, I write the new numerator. Now I need to find the new denominator. Same thing, calculator. Okay, so pull the calculator out, multiply everything in the denominator. There was a 1 here because this is anything that doesn't have a denominator is 1. Times 55. So 55.85. Okay, times 4. Times 1 again. Equals, I think we need to clear that. 55.85 times 4. 223.4. 223.4. Let's see, there's no units on the bottom. Oh, but what was on the top? Grams. And that was iron oxide, right? It didn't have room to write it, but it was Fe2O3. Last step, and we are done with the calculation. Just doing the arithmetic takes quite a while. 31940 divided by 223.4. Wow, 142.9722. Which of those digits do we drop off? 144.92. 142.972. Sorry about that. Scratch that out. 142.972 grams. Well, when I go back to my problem, I can see these zeros are going to count because they're after the decimal to the right. So I've got 1, 2, 3, 4, 5 known digits. I can keep 5. 1, 2, 3, 4, 5. So the answer is going to be 142.97 grams. So many grams of rust I can make from just 100 grams of iron, like an iron nail. Alright, well, go study your chemistry hard, learn how to do the math problems. You got worksheets to do. You can refer back to this video course. And as well, read the notes on the first part of stoichiometry. It introduces all this as well. Well, good luck. Study hard.